The answers are, so is it linear? Yes, yes, yes. No, this one is not linear. No, this one is also not linear. 5. For each table of values below, does it represent a linear relation? A is, B is, D is, C is not linear. A, B, and D are all linear. C is not linear. And then the question said, question 6 said, graph the linear relations. You look perplexed, Emma. Can I address something? You have a question? Okay. Yes. Then it's too short. Then take that piece out and go to the next piece. Okay, so there's some consternation about C. I'm sensing. Okay, so question C, the x's go up by 1 each time, but the y's do not go up by the same thing every time. I mean, it increases by the same amount every, like it goes up by 2, and then goes up by 4, and then goes up by 6. But from one jump to the next, for something to be linear, the first thing to check is, does it go up by the same amount every time? X's do, 1, 1, 1, 1. Y's do not. Up 2, then up 4, then up 6, then up 8. So because one side jumps even and the other side does not, it is not linear. Yes, Hayden. In that box on the table at the front. You should have gotten one last week. You were here. You can take one. No. So, I'm out of 0.5 lead. I think Gershon took my last piece of 0.5 lead last week. Are we cool with why it's not?
Yeah.
You can say no. Like if you want to. We're good? Okay. So then when I assigned these, I said, there are 3 of them that are going to be linear. Question 6 wants you to graph the linear ones. One of them you cannot graph. One of them you need to extend the table. And one of them will fit nice. This is the one that's not going to fit on the graph. Even I think if you rejig the table, it still won't fit. This is the one that I intended for you to rejig the table. This is the one that would fit as is. So the graphs for 5A and 5D are going to look like this. If you had said that 5C was linear and then went and graphed it in 6 like you were supposed to, you should have seen it was not linear. Would anyone like me to graph 5C to show you what I mean? There's a few that nodded, so I'll go ahead and I'll graph 5C. So I need to flip ahead. 5C looks like this. I'm just going to write out the table. 0, 0. Oh, yeah, right. 1, 2, 3, 4, and then 2, 4, 6, 8. No. 2, 6, 12. 2, 6, 12, and then there only was a 4, and 20. Okay, so 5C would have looked like this. That's the table for 5C. X, Y, 0, 0 is right there. 1 and 2 is right there. 2 and 6 is right there. 3 and 12 is going to be there. 4 and 20 is going to be up here somewhere. So if you look close, like you can't draw a straight line through all these points. You'd have to, what you would end up doing is curving the thing. It's ever so slightly curved. If you drew a straight line, you get something like that, or like that, or like that. Like you'd miss the pieces. There is no way to draw 5C with one straight line. Okay, 7 wanted you to complete the table. There's 7. You just plug it in X values. 9 wanted you to complete the table. There it is. Sorry, there it is. Comments, questions, concerns about number 9. Excuse me. And then number 10, create a table of values for each linear relation. Use values from -5 to 5. 10 looks like this. That's A and B. And C and D. So I just wrote down the equation for each. I put the table of values on the side, and then I graphed the thing. A, B, C, D. And then question 10. D and E are those guys right there. Whew. Questions, comments, concerns about anything I gave you from Friday? Okay, then, oh shoot, I was supposed to do some photocopying at lunch and I totally forgot. Then flip the pages. Find me this page. And back and this and that, and you are. Hello, Alex. Super duper, man. What's going on? Oh, always, but it's fine.
That's what I do all day.
So. Okay, here we go. Sorry about that. Here we go. Yes, Jackson, do you have a question about? Very. Oh, he has a question. Not related to the class. Okay, here we go. So, linear relations. This is going to combine a little bit of what we looked at last chapter with what we looked at last week, Thursday, Friday. So, we're going to start making some equations and graphing those. It's going to be great. A variable that relies on another variable to determine its value. We say that that thing is called a dependent variable because it requires the work of another variable to tell it what to do. You guys are dependent on someone else. When your parent or guardian does their taxes, you get listed, as far as the federal government is concerned, you guys get listed as dependents. Why? Because you guys are not necessarily in a position to totally fend for yourself to the optimal level that you would if you were a little bit older. Okay? That word dependent means you rely on someone else. You need someone else to tell you what to do. So you guys are in that awkward position where some of you are like, I don't even know what to tell me what to do. I digress. Dependent variables require another variable to tell them how to behave. Dependent variables when we graph them, and we're going to today, get graphed on the y-axis. This convention is what we do. A variable that does not rely on another variable, does not rely on another variable to determine its value is called an independent variable. It is a strong independent variable. It does what it wants. Or maybe you make it do what you want it to do. You get choice. This variable has choice. It has options. And then depending on what the independent variable is defined to be, you get to choose that. Your dependent variable will respond in kind. The independent variable gets graphed on the x-axis. So if you have, Liam and Jackson, if you have no context to a problem, for example, I'm going to do 3 examples today. They're all going to have context. One of them is going to be a carnival being held. Actually, 2 of them are going to be about carnivals. And the third one is going to be about running at a particular speed. All of those have variables that will make sense in a given context. If you don't have variables that are given to you in the context, then x and y get to be those variables. X is independent always, y is dependent always. An example of this stuff is the stuff that we talked about last week. one of the examples I gave you when we were talking about discrete versus continuous. Ooh, Brielle, did you ever go to Fresh Slice and ask them?
I asked for half the slice, and she's like, who's gonna buy the other half? I was like, figure it out. She didn't tell us.
So she said no. Ultimately, I appreciate you trying.
She said, who's gonna buy the other side?
That was the most passive aggressive way she could have said no. I mean, the follow-up question was, that's neither here nor there. What would you charge me? But that's the kind of stuff we're talking about. You don't walk up to Fresh Slice, usually, and say, give me all the pizza you can give me for this much money. You can, but you don't. But you don't. Often, usually, like how a normal person orders food is you walk into your dining establishment, you pick your food, you eat the food, and at the end of the meal, the restaurant comes to you and says, you ate this, you owe us this. Or you could be a criminal. Not an option.
I'll dine and dash.
No. Just okay? No, it doesn't help, Hayden, when you've already missed what you've missed. You're just going to confuse yourself with the silly answers, okay? So, there is, well, that's whatever. Then, we just started, man. Like, there's nothing to be confused by here. Okay, shh. No. Dilkaran, not again. He's across the class from you. Hayden, don't talk back to him. You know what? Fine. I'm just going to keep going. I try to give you examples to help with the things, but I'm just going to keep going. For example, read, when graphing distance travel as a function of time, distance is dependent, time is independent. The longer you travel, the further you've gone. Period. End of story. A youth group, no, you're still covering ground, even if you're going in circles. You know what? No, I said I wasn't going to do it. I'm just going to do math. Here we go. A youth group, here's the first example, is holding a carnival. The profit in dollars is 5 times the number of students who attend minus $100 for the price of food. So, profit, for those of us who might be a little confused by the language, profit, Hayden, if you had a writing utensil that you could write things down with, that would be helpful. Profit is money minus expenses. All the money you get holding an event is not your money. First, you have to pay the people you hired to do the food or the drinks or the music or whatever. You have to pay people out of what you make. What you have left over after you've paid people, that becomes your profit. So, the question says the profit in dollars is 5 times the number of students who attend minus $100 for the price of food. This sounds an awful lot like the stuff that we were doing last chapter. How could we make an equation out of this second sentence? The profit in dollars is 5 times the number of people who attend minus $100 for the price of food. P for profit equals S for students. Student sounds good. Minus 100. It comes straight from the kinds of things we were doing. Profit, we don't know what it is, let's call it P. Is equals 5 times the number of students. We don't know how many students are showing up, so 5S, Marcus says for students, minus the $100. This is the equation we're going to use. Now you've got, so in this thing here, which is the independent variable, which is the dependent variable? Independent is the number of students. You don't, well, I'll say it this way. This is what is fluid. I mean, obviously you can't control the students that come to your party, but you have more control over the students that come to your party than you do the profit that you're going to make. Profit is entirely wrapped up in the students that show up. Jackson, stop talking. So if S is independent, that means profit is dependent, and profit dependent relies on the number of students who actually show up, not the other way around. You don't throw a party and say, my profit's $600. People show up accordingly. People are going to show up and they will determine how much money you make or lose. So when we graph these things, this is where the dependent gets thrown on the x-axis, the independent gets, sorry, the y-axis, the independent gets thrown on the x-axis. And so now we start choosing values. The independent, when you make a T-chart, it always goes X then Y. Students are what we're going to label over here in the independent. Profit is what we're going to label on the dependent. And now we get to choose examples of students that show up to see how the profit behaves. What's the fewest number of students that can show up to your party? 0. You could have the entirely miserable, sad scenario. Nobody shows up. Can you have negative people show up at your party? No. So now all of a sudden, the context of the problem is dictating to you values you are allowed to have or not allowed to have. So what we're going to do here is we're going to choose values that make sense with the problem. For example, there's no such thing as negative people. Can you have negative profit? Yeah, it means you lost money. You spent all this money on food and no one showed up. I'm sorry if I'm drudging up horrible memories of parties on past. So, let's start picking some values for people. Look at the equation. I've got P equals 5 times S minus 100. What are some values that could make sense to pick for the number of students who show up? 150. 50. Okay. We're going to go down here. We're going to toss a 50 down here, right at the bottom. And we're going to take this and we're going to plug it in. So, P equals 5 times 50 minus 100. This value gets plugged in for S, and we're going to figure out how much profit is there. Five times 50 is? And 250 minus 100? 150. So if people show up, your profit is $150. Cool. If nobody shows up, what's your profit? Negative 100. Okay, so then to flush out this data, let's pick some values in between here. What is a smart value to pick here? Take a look at the equation. There's a particularly important point. We already did 50. Pay attention, Hayden. Still haven't heard it. Are you just guessing, Gershon, or do you have a good reason for picking the numbers you picked? They're all even? I mean, even works, I suppose. 15, okay, if we pick 15, 5 times 15 is 75. 75 minus 100 is negative 25. So we're getting warmer. Why is 20 a really good number to pick? Look at the equation. Because that's the break-even point. If you look at the equation, 5 times the number of students show up minus 100 is equal to your profit. If you plug 20 students in here, 5 times 20 is 100, and then 100 minus 100 is 0. So if I shove 20 in there, that's where we break even. And now for fun, let's just shove a value in between 20 and 50. 40? Sure, 40 works. I heard that one first. And I already done the math on 40. 5 times 40 is 200. 200 minus 100 is 100. And so now let's go ahead and graph these things. You guys will be given empty graphs, and you need to figure out how to graph your axes, how to label these things so that you can fit the most amount of data on here. Now, we are not allowed to have negative people. So, x is 0 is going to be our smallest horizontal value. Where x is 0, what line is that up and down? Yeah, but where the x value is 0, what line is that up and down? That's the y-axis. So the y-axis is where this is all going to start. Jeffney, TV's over there. Dokran, stop distracting my students. Yes, you are. You're doing everything you're doing in a way to be distracted. Stop it. I wasn't going to say distracting, but then I would have caused a stir. Okay, so because our smallest value in the x direction is 0, or horizontally is 0, and that's where the y-axis is, I'm just going to put the y-axis along the side of the page, along the side of the grid. And now we have to decide what, what values we're going to go up by to maximize the amount of space we use for the y-axis. Now I have some tips here. Picking axes. This is not picking axes. I'm not giving you advice on how to shop for an axe. Hayden, stop talking to Rain. You can either pay attention, find a writing utensil, or you can go sit on the couches. Okay. You've asked, where are the pencils? Where's your writing utensils? Okay. I didn't want to hit Gabe in the head, so I should go way overshot. Here we go. Picking axes. Use, I thought he had. You got a lead? Bring your own writing utensils, guys. Use at least half the graph. Show up to, remember the first day of school and I was like, these are my minimum level expectations. Show up prepared. We're not doing that. Use at least half the graph. So you want to separate out your values so that you're maximizing your space. You must have consistent spacing. So what that means is every gap needs to go up by, every jump here needs to be the same amount. Or maybe you go up by 2s, that's fine. However you're jumping, you need to be going up by the same amount every time. I'll demonstrate that in a second. Values on your grid should be, and I'm going to put this in quotes because it doesn't really mean anything, good. What do good values even mean? Well, good quote-unquote values are things like going up by 1s, going up by 2s, going up by 4s. Sometimes 5s are good. You want to avoid 3s. Sometimes good values mean things that are easily split. Like if I go up here by 1s, I know exactly where the halfway point is. If I go up by 2s, so I know halfway between these two values is going to be 1. If I'm going up by 4s, I know halfway there is 2. Like things that are easy to estimate. Going up by 3s, cutting things into thirds, miserable. Going up by 6s, 9, awful. Don't do it. 1s, 2s, 4s, 5s, 10s, all good. Multiples of 10 are good. Certain multiples of 5 are good. Some are bad. Don't go up by 15 because it's also a multiple of 3. 25s are okay. But like, so you have to be deliberate about the numbers that you choose based on the information that you've got in the problem. Okay, so this is important. And the only way to really wrap your head around that is to try a few. So let's try a few. This is the data that we've got. We want to cover the spread from negative 100 all the way up to 150, and we have to place those values on here. What should we go up by? Sorry? 20s. So if I'm starting down here at negative 100, going up by 20s goes negative 80, negative 60, negative 40, negative 20, 0, 20, 40, 60, 80, 100, 120, 140. If I start right at the bottom, that means I would get to 160 here. That would cover the spread. Sure, let's do it. And then I'll show you what the other class did because they could not go up by the same amount. So negative 100, negative 80, negative 60, negative 40, negative 20, 0, 20, 40, 60, 80, 100, 120, 140, 160. So yeah, there's no reason why we couldn't do that. It covers the spread, gives us all our data. When the y-axis is equal to 0, what line comes out of there? Who said that? The x-axis. Where the y-axis equals 0 is where the x-axis comes out. So now we can throw that down. And now we need a scale for this guy. It does not have to be the same. And we want to use as much of this space as possible. So what could we go up by now in this direction? You want to go by 5s? Every 1 square is 5? Because if you want every 2 squares, you want every other square to be 5. Cool, okay, so if we do every other square, it's going to be skip 5, skip 10, skip 20, skip 30, skip 40, skip 50, skip 60. Yep, it would fit. And it would use more than half. It's great, let's do it. So Marcus is absolutely giving us a totally awesome scale, which incidentally is the same one that my A block class did this morning. Every 2 squares we're calling 5. And it works for our data because all of our data is a multiple of 5. Would this scale work if we'd picked anything in here that wasn't 5? Or a multiple of 5? No, it'd be terrible. Because half of 5 is 2.5. Half of 2.5 is 1 3/4. Like, it would be awful to go in between. But because of the values you guys picked up here, calling every 2 squares 5 more works. So let's do it. 15, 20, 25, 30, 35, 40, 45, 50. Every gap goes up by the same amount. And now we can plot these points on the graph. 0 and negative 100. So 0 in the x, negative 100 in the y is down here. 15 and negative 25. Ooh, negative 25 is going to be tricky. Because halfway between negative 20 and negative 40 is negative 30. So we're trying to go like a quarter of the way down here. You got to be careful with ones like these. But 20 and 0 work. That's that guy right there. 40 and 100 work. And then 50 and 150 is going to be halfway through there. Between 140 and 160. That absolutely works. Now, is that linear? Could I draw a straight line through it if I wanted to? You bet. Am I allowed to draw a straight line through there?
No.
Why not, Raven? Does it help me if I tell you you're right? You're right. I'm not allowed to. Why?
When you said yes, you didn't say anything, but when I said no,
Juno. Which is the problem? Are you allowed to have fractions of money? Are you allowed to have fractions of people? No. That's why you cannot connect the dots. No, does not make sense to join the dots. No, fractional people. And I've heard all the jokes. You don't need to make them. I'll make them for you right now. What about the amputees? They still count as whole people. What about really small people? They still count as whole people. What about conjoined people? That's a different question. Would you have to pay? If it depends on how they're conjoined. If they're conjoined in such a way that they're eating for two, they count as two people. If they're conjoined in such a way that they're not eating for two, I've never seen that, they would count as one person. Because you're charging for food. So if the person's going to eat, even if they're, cut off at the leg, he is a whole person. Well, you charge for food. That's what you're coming down. That's what this is all about. You're trying to make your money back on food, so it would make sense to charge for the people showing up to eat. So I cannot connect these dots, but could I fill in more points? Absolutely, I could fill in more points if we had more data points to fill in. But this is what this one's going to look like. Questions, comments, concerns. Okay, so if I want to show you what my Block A class did, because their scale was slightly different than yours. So yours was a lot bigger this way. Block A decided to go up by 25s instead. They went up by 25s, and there's the purple points are the ones that are the data points from up here. The green ones are, because they picked a 25 scale, the green points were easily added to the graph. This one isn't quite so easily added because like 25 was a quarter of the way between -20 and -40. So in this case, picking a 20 scale works. Is it as good as picking a 25 scale? Maybe not, but it absolutely worked. Okay, what I want you to do is I want you to flip the page and I want you to try this one. No, you may not leave. You are trying this one as an example. I will help where needed. No, you may not leave. We're doing this one. This is what you're doing. This is your task on your market set go. No. It's very similar. Now I want you to do it. No, it does not have the same numbers. Depends on the iPhone you have. It's the old lightning charger. Okay. It's similar. It's certainly similar. If example 1 made perfect sense to you and was easy, not everything. Sit right beside him. Okay, try it. Gentlemen, try this question. It's exactly the same as what I just did. Set it up the same way. We'll flip back, look what we did. Try it. Shobit, I gotta run down to the photocopier for a second. I'll be right back. When I come back.
Oh no, Brock just snapped me.
Yeah, I'm charging my phone. Yeah? Fucking idiot. He gave me the charger. Okay, put on the apple.
Yeah, but over here's like. He lost his other one.
Oh, we gotta put on the gas.
Were they actually?
I didn't even know. My numbers are all. I went 0, 1, 30.
Yeah, how did they take off that fast?
Which way do you like it?
And then you got a free pair of AirPods.
I'm whipping it out. What number should I use? We'll put out. Put out what? Straight on. What? That's my reach. That's the last part. This innocent guy.
Same thing? Can I use the same
Sean, why did you steal the Starburst?
I'm gonna get my calculator. I'll just put
Not a fall back. Okay, fuck you.
It's literally yellow. What the fuck are you on? You stole it. No. No. I'm not eating stolen candy.
Yeah, like shut up.
I'm not eating stolen candy. No, no. You want to do it because they started this one?
Don't
No,
look
yeah,
at
no, no, no. What is this a night machine?
Okay, so we're done?
almost.
I'm gonna write it. Okay, so if we're done, let's take a look at it.
You missed 4 times.
Yeah, we still have to.
How long you guys? But then I walked in and everyone's pencils were down. It's like, we're done.
It was a little bit of a party.
Sounds like it.
Yeah, but
Let's go. You've done nothing. Okay. This is exactly the same Raven. You have to try it.
No, you have to take a little bit.
But conceptually, it's exactly the same.
I'm putting it on every one.
Yeah, I put it on everyone.
Which one are we talking about here? You want to figure this one? You're talking about what? So this, these are X's. X's go left and right. These ones are going up. I'll go numbers that you.
No, I did it wrong.
Starting at negative 150 would probably be a good idea. Because that's what 0 is, yeah. No. Now this is where you need to go up by a good amount. Like, should it go up by 20s? Well, if you go up by 20s, it'll go from negative 50. No, that's going up by 20s. You just want to go by 30s. By 20s? Wrong. No, we can try 20s. Well, here's a better one for you. If this is 50, 50 is a multiple of 25. Going by 25 would be good.
It goes to 260. 260, sorry, 260. What are you going by negative? What? I'm confused.
Because, why? I started out with 50. I didn't pick the best numbers. You start
Oh, and it'll be negative. No, it's plus 10 now.
Going by 25. You only went up by 50. Going by 25, you take it from 100 to 50. So negative 150, negative 125, negative 100. Yeah. Negative 55. You're going up by 25.
Oh my god, this is hard.
No, it's
You try going by 20.
I don't want to.
what's 20? What's 50 minus 25?
Just count how many spaces there is.
Yeah, extend it by.
And up again, it's going to be negative 25 up 25 is 0. But you want to be careful here. You want to make sure you're going by that's that line. That's that line.
I'm gonna see how.
This is the 0 line. You're starting with separate on the whole.
And then 25.
25.
My friend did that and he got top 10.
25 plus 25.
Ours is pretty good.
Who's the best player on your team?
So you're going by quarters.
I agree.
25
Probably
cents.
8.
Yeah, from Little?
50 plus 25.
Who's on the junior board?
Oh, yeah.
75 plus 25 is? So 75 plus 20. 75 plus 25 is 100. Yeah. 150. Okay. But you're almost done. Nice job with those points. Well, what are you going up by? You want to make more careful. Careful. Because your spread goes from 0 to 90. If you go every 2 5, you're not going to hit 90.
V130.
Jackson.
Well, given the group you had, that might
Yeah,
be
yeah.
still your best bet. You still need to just stay on. Okay, let's talk about this, guys.
When I assign you homework, you may go. Have you done all of the things I've wanted you to do? Okay, here we go. So, lots of you have the equation. That's great. You said P equals 3S minus 150. That's great. Now the hard part comes where we're starting to pick values. X is independent. Independent is students. Profit is Y. So, I'm picking values. I'm starting with 0 because that's the fewest number of students we could have. All of you should have that data point. 0 and negative 150 should be the first thing you have. Then your data is going to, the degree to which you are able to pick good values for your X's is going to dictate how well the next part of this graph goes for you. Because this number here, this number here is 150. I'm going to pick values. Rabin, pay attention. Why are all of you having candy? I asked Dilkaran to put all of that away. Raven, pay attention. Gershon, stop being a distraction. All I want you to do is pay attention here. We should not be eating suckers. Raven hasn't done any of the work. He does not deserve a sucker. So, also, unnecessary. I'm picking values that go into 150 nicely. I would pick things like 25. I'm going to go up by 25s here because I can see that by multiplying here, I'm going to end up multiplying this thing, S, by 3, and then taking it away from 150. So because this number is 150, I'm going to choose multiples of 25. If this number were 100, I would pick 10s or 20s over here. But because that's 150, I personally would pick 25. You can make anything work, but that's what I would pick. So I'm going up here, 25, 50, 75, 100, and we're going to see what that does to our data. So if I pick 25 here, 3 times 25 is 75. 75 minus 150, negative 75. And if you need a calculator for that, that's fine. 3 times 50 is 150. 150 minus 150 is 0. 75 times 3 is going to be, sorry, 225, thank you. And then 225 minus 150 is going to be 75. And then 100 is going to be, 3 times 100 is 300 minus 150 is 150. So that's the data that I need to now fit on this thing. If I take a look at what I've got here, if I'm going to start with -1, and remember, up and down are Y values. Up and down is Y, that's profit. So I'm starting down here at -150, and it would be great if I could make it all the way to positive 150. Well, if I go up here by 25s, like most of my data is all multiples of 25. I can go up by 25, I'm going to get -125, -100, -75, -50, -25, 0. Jackson, stop talking. 25, 50. I'm pretty sure I heard Jackson's voice. 75, 100, 125, 150. Unless I skipped something in there. I think I oopsed in there. 25, 50, 75, 100, 125, 150. Did I screw up somewhere in there? This is do. Why is that different than what I got before? Oh, that's why. Never mind, we're good. So, wherever the y-axis is 0 is where the x-axis is going to come out. And I need to create a scale that'll address all of these values. Now, there are 20 lines here. So if I go by 5s, that's going to take me right to 100. So 5, 10, 15, 20, 25, 30, 35, 40. Now, these numbers aren't going to be great for anything in between, but I picked all my data such that it's a multiple of 5, so this will work. 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. I plot my points, 0, negative 150. 25 and negative 75 is going to be right there. 50 and 0 is going to be right there. 75, 75 is going to be right there. And 100 and 150 is going to be right there. Now, because of the scales I've chosen, the in-between numbers are not great to add. I mean, it's doable, it's just not going to be super pretty. But these ones are obvious to see that this whole situation is linear, and it would not make sense to connect the points because, again, people are not fractional. And now, based on our data, we can answer the bottom question. How many students have to attend to make a profit? Or, Dilkaran? Nope, Gershon. You said 51. Or, well, 50 is your break-even point. There's one 4-letter word I'd add here. No, that's not a 4-letter M word. It starts with an M. 4-letter word starts with an M. Sorry, Brielle? I thought you said something. More, I heard. How many students to attend your party? At least 51. 52, 53, 54, anything more than 50. We'll do it. Okay, I've got one more example for you and then I'm done. Flip the page. Here we go, one more example. This is the last one I'm going to do and then I'm done. Write an equation. So we have Sundeep running at an average speed of 10 kilometers per hour. That's pretty good. Kilometers per hour. We want to write an equation that relates the distance that Sundeep has traveled and the number of hours that she's been running for. We want to create a table of values for this relation. So I will give you the relationship. When you are looking at things like distance, speed, and time, the relationship between all three of those is always your distance traveled is equal to the speed at which you're running times the time you've been running for. So when that's the equation, we can shrink this down. I'm going to call it D, my distance. Speed, we're told, is 10 kilometers per hour. And T, I'm going to call time. So I'm condensing that distance equals speed times time down into D equals 10 times T. So that's the equation. Which one of those variables is dependent? Which one's independent? T is independent. And D is dependent. Dependent. 98% of the time, time is independent. You don't get to choose time. Time's going to do whatever the heck it wants to do. It's going to move at 1 second per second through the universe, and that's going to be that. Unless you travel at the speed of light, and then things get weird. So, if time is independent, this is what's going to go on the x-axis, and dependent distance is going to go on the y-axis. Are there any restrictions on values for time? You cannot have negative time. No negative time. So now, based on this equation, let's go ahead and figure this out. Our independent is time, our dependent is distance. So let's pick some values for the time and see how far Sandeep could have run. Smart value always to pick is 0. And Marcus, if no time has passed, how far has she run? Nowhere. Distance traveled is 0. What are some other smart values here to pick for time? Given that you're talking about someone running. Thank you for that example. Because the speed is given in kilometers per hour, time must be in hours. Okay, so 1 hour I'm actually going to toss down here. 1 hour makes a lot of sense. After 1 hour, how far has Sandeep run? 10 times 1 is 10. But Hayden was not totally far off earlier. Fractional hours makes a lot of sense. But 10 minutes is 1/6 of an hour, and sixths are terrible. What fractions of hours would make a lot of sense? A half an hour? Sure. Half an hour is 0.5. After half an hour, how far has she gone? What is 0.5 times 10? 5. So then let's keep this going. After an hour and a half, how far has she gone? Assuming she keeps the same rate? 15. After 2 hours, how far has she gone? I mean, we could have gone quarter hours in here too, but we didn't. So now then this is our data. There's no such thing as negative distance here, and there's no such thing as negative time here. So 0, 0, where our axes meet, the origin, is going to be in that bottom left-hand corner. Time goes on the x-axis, distance on the y-axis. And now we need to pick a good scale. I want to use as much of this grid as possible. Because we break time up into reasonable chunks. We talk about, 15 minutes, 30 minutes, like we go quarters. What I'm going to do is I'm going to choose to break my time up. I'm going to say that every 1, 2, 3, fourth line here is 1 hour. So I'm going to count up again. 1, 2, 3. This fourth one is 2 hours. 1, 2, 3, 4. This fourth one is 3 hours. And what that gives me is, we could have gone further, but it gives me a nice fraction. Because a half an hour is right there. So this is going to be a quarter of an hour, and this one's going to be 3/4 of an hour. But everything there is broken up. For the distance scale, what's a good scale for distance? Did you say a good scale for distance would be time? Okay. What would be a good scale for distance? If I go up by ones, it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and we're going up by 20. 20 would go 5, 10, 15, 20, and now I'm done. 5, but every other one we could do. Or actually, there's a better example, not a better example. There's a different example I want to show you for, sorry? No, I'm going to go up by 2s. And I want to show you, but you didn't. I want to show you what it looks like when you go up by 2s. Because there's a nice thing that happens when you go up by 2. When you go up by 2, it's really easy to see the in-between. So 0, 0, at no time, no distance has been traveled. Should use a different color for this. After half an hour, she's gone. After half an hour, she's gone. How far? 5. So 5 is halfway between 4 and 6. So even though 5 is not on our scale, getting the halfway point between 4 and 6 is not a hard thing to do. After an hour, she's up here at 10. After an hour and a half, she's up here at 15. After 2 hours, she's up here at 20. And are we allowed to connect these dots?
Yeah.
Yes. You can have any fraction of time. You can have any fraction of distance. These dots we are allowed to connect. And we get something looks like that. Nope. How far does Sandeep run in half an hour? Yes, 5. To read that off the graph, you go from half an hour up to the point and over 5K. How long does it take her to run? 15. You go up to 15 on the y-axis. You go over to, 15's right there. You go over to the line and you go down. 1.5 hours. Here's your homework. Flip the page. I want you to do questions 13 and 15. That's it. You need graph paper. Here it is. You may not go to the individual. Nope, there's only 10 minutes left. I'm not allowed to let you go. 1, 2, 3, 4.
Last lesson.
Before lunch?
No, last lesson. Oh, like.
Well, that's example. But now I can't. Okay, yes. If it's that bad, go fast. 10 minutes. Okay, this should be grid paper for all of you. It's double-sided. One on one, one on the other. There you go. It's double-sided. One on one, one on the other. Does anyone not have graph paper? Well, Ab needs and Jeff needs. It's coming, I think. Somebody else is gonna pass that back. Okay, guys, pass them back. Pass them down. Okay. I have even better graph paper I could have given you guys. Take a look at this stuff. This is the stuff I think your sister would have.
It wasn't that bad. I don't like the stuff that goes all the way to the corner of the page. That stuff I hated.
Teeny tiny squares.
I remember when we used to have big things like this.
Yeah, the huge grid.
Yeah, those were.
Yeah. They just get progressively smaller. My favorite graph paper right here. I think math teacher's gonna have favorite graph paper.